Hello and welcome to this tutorial. My name is Ismail Badran and I am from Al-Najah National University in Palestine. Today we're going to talk about designing a calculated question using Moodle, which is a specific type of questions that allows the calculation or the estimation of a value and entering it in a box rather than just the regular multiple choice questions or the true-false questions. So the example today, we're going to use an example from gases in chemistry, which the ideal gas equation, which is ruled by PV is equal in RT, where the P refers to the pressure and V is the volume, N is the number of moles, R is a constant, and T is the temperature. Of course, you can use any equation that you prefer, rather in physics or chemistry or even calculus. Here we need to define the variables. So for this type of questions you need to define the variables. So P is a variable here that lies between any values you want. In this case we're gonna vary between 1 and 2 atmosphere, and we have to give it a symbol which is P inside these kind of brackets. It has to be these brackets, by the way, okay, not any regular brackets. And we have also the volume as a variable, so it's a V. Doesn't matter what you want, like V capital or small, just you decide. It's between these two brackets again, and we need the volume to vary between 20 to 80 liters. In this case, each student will obtain different values than the other students. We're going to fix the R, the constant. It's 0.0821 atmosphere liter mole minus 1 Kelvin minus 1. And here T is also a variable, which is I'm going to refer to that by C. And it's going to be between 5 and 80 Celsius. You can choose whatever value range you like. So in this case, N, the number of moles would be equal to PV over RT, but we have to change, of course, the Celsius into Kelvin in this question, which is something I'm going to do in the formula. The text of the question will say calculate the number of moles of an ideal gas, or for an ideal gas that has a pressure of this. So it's not a direct question in this case. The P here will vary between different values, and in these type of questions you have to make sure to put the units. It's very important to put the units, and in this case V in liters. The gas temperature is this in Celsius, and here I'm giving the students the value of R. In this case I'm just gonna, because this is type of tricky questions, and to avoid any problems in grading such questions, I have added some instructions in Arabic that ask students to put the value as only a number. So the answer should be like that, 1.2 for example, or 10.5 or whatever, without any units, without any text, without anything. And this dot, the decimal point, has to be a decimal point, not a comma, not any other symbol. Okay, so let's fire this up. Here's the formula that I have used, because this type of questions will require you to put a formula. So in this case it's PV over RT, so it's P as a variable times V between two brackets, regular brackets in this case, divided by RT, and in this case I have converted Celsius into Kelvin using this type of formation. So this question is straightforward, no problems. You just need to use the star for times and the forward slash for the slash for divide. So I'm good to go here. I'm gonna go to Moodle. This is my Moodle from my university. So I'm gonna go to question banks, and from question bank you can choose any category or whatever you want to put this question in. So this is just an example. So I'm gonna go to create a new question, and here as usual you have the multiple choice, true and false, and so on. So the one we need here is the calculated simple. For some reason I have tried the calculated. The best choice here was for me is calculated simple, which is this one, calculated simple. So I'm gonna click add. I'm gonna start with naming this question. So I'm gonna call it ideal gas law, whatever you like. And here I'm gonna paste the text of that question that I have prepared. So this whole stuff here. Okay, so the question is good to go. Calculate the number of moles for an ideal gas that has a pressure of P. Remember this, because this one has to be exactly the same as in the formula, and this is where the problem starts. In atmosphere and V liters, the gases temperature is so and so and R. So this looks good. Gonna go down a little bit. Here you can assign whatever marks or grades for this question. You can change, of course, this later. And here is the formula. Don't use equal. Some people they use equal and they have problems. Just paste the formula as is. So I'm gonna take this and put it here. Okay, so PV, because there is equal already here. You see that the formula equals this. So PV divided by RT. You have to give a grade because otherwise it's not gonna work. So if this is usually 100%. And here is the tolerance, which is something important. You have two choices for the tolerance. You have relative tolerance or nominal. For relative tolerance, this is like 1% of the answer. So if your answer is 100, that will give you 100 plus minus 1, something like that. For the decimal, or sorry, for the nominal one, in this case, the answer would be whatever plus minus 0.01, okay? So the best thing here is to choose actually relative, and usually I use 0.02. If you want to be more flexible, you can assign as 0.03. And now the answer display, of course, it depends on the question, so you can always play with that. Let's keep it as 2 decimal places for now, and we'll see how it goes after. Now this is good. In unit handling, leave as this as no units. And for the multiple tries, you don't have to change anything here. Now we need to find the wildcards, which is x and y, or whatever variables. So click here. Hopefully he will find them from the question. Remember we have 3 variables. So the PV and C. So let's see what he did. Okay, he's not showing you that. So if you click here, wildcards parameters used to generate the values. So click in there, and yes, here they are. So PV and C, as you see. So he found them in the formula. Remember now we need to assign the minimum and a maximum for each one. So we said pressure is going to go between 1 and 2. Where is it? Okay, here. So 1 and 2. And 1 decimal place, that's fine. For the volume 20 to 80, so that's 20 to 80. Also 1 decimal place is enough for this. For the temperature 5 to 80, so this is 5 to 80. Okay? Of course, if you have other types of questions that require a variable, let's say, to line between 0.01 and 0.1, in that case you have to increase the number of decimal places to fit to the smallest one. So in this case I will choose 4 decimal places in this case. Let's get it back to 580 as we said. Okay, so now you can generate as much as you can of this. Okay, so if you choose 100, let's say, he will generate 100 different variables. But before that, let's click 1 and see what's going on. Okay, so wildcard values. So I'm lucky here, it works well. He said the pressure is 1.8. He gave me a volume of 24, and this is R, and he chose a temperature of 37.7, which lies between the 5 and 80, and he gave me an answer of 1.7 mole. So you can check that, of course, and he says correct answer. In some cases you will get error. In that case you have to go back and keep checking these values and a minimum and a maximum in order to fix the error. According to our tolerance, the 1.7 lies between 1.66 and 1.73. So any answers between these two values, he will or she will correct that as correct. Let me play with the tolerance a little bit and I will show you what I mean. So if I go here with the tolerance and click 5, let's say, and click generate again. So now of course he will give me different. Okay, so he gave you different values, slightly different values. The answer is 1.87, and now we are more flexible between the answers. Okay, so let me get back that to 2. Now I'm gonna generate 20 of this, 20 different versions. Okay, click generate, and now what? Okay, here we go. So he generates 20 sets of this with completely different values for each case and the maximum and minimum for that one. You can even preview that before you save it. Okay, so sorry, there is no preview here, so you have to save the changes. Unfortunately, for this type of questions, you have to set it only once. And I found that when I go back and try to edit the questions, I have problems. So you set the 20 sets, that's fine. You just click save changes and you don't go back and check that question. It's good to go. I'm not sure if you have preview here. Okay, so we have preview. You can always preview that question. So now he's giving you a question. You can calculate the n in that case, double check if it's all correct. You can put the answer here. Or even you can fill in the correct response. And here's the response that he had, and you can try that and with your students and see if it's working. I have another example which relates to the pH. So the pH, of course, in chemistry it's minus log H plus. So you can generate another question. Okay, with the simple calculated, and here let's say pH. Let's call this pH. Let's say calculate the pH of, let's say, X molar of HCl. Just a simple question, okay? Now, so of course HCl it's a monoprotic acid. It's going to produce H plus with the same concentration. So here, the formula here for log is log 10. Log alone will mean len, natural logarithm, but log 10 will the log. I think it's going to be like that. Let's try that. I'm not very sure if it's going to work, but let's try it. So this is X, so log 10 of X, okay? It's actually minus log, sorry. I have made a mistake here. Okay, it's minus log. So minus log, this 2, okay, let's try that. And find wildcards. Hopefully found it. Okay, so we found X. Here I'm gonna tell him that this is between 1e minus 3, because this is another way, to 1e power minus 2. So I'm going to give you small concentrations. And the reason I chose that is to show you the possibility of adding the values in scientific notations, okay? And I'm going to do this. So let's call it generate and see if that works. Okay, nice. So log 10, and it works very well. So for HCl of 0.01 molar, the pH is indeed 2. And look at that, the students can put any values between these two numbers, okay? And as I said, you can always change the tolerance the way you like. Let's generate 50 of this. It's up to you how many you want to generate, and how many students you have. And look at that. Oh, okay. So here it says infinity. And because he chose a number of 0, and it's good that we get this error so we can fix it. Let's look at that. 1 to the minus 3 to the 1 to the minus 2. Okay, so the reason he chose 0, and it's nice always to troubleshoot these things, is because of the decimal places. You are asking for a minimum of 1 to the minus 3 and 1 to the minus 2, and the decimal place is not enough to cover this range. So if we increase this to, let's say, 4 decimal places at least, I hope it's going to work. I think it's working now with no errors. Okay, so good luck with this, and hope you try it and you enjoy it with your students, and have a good day.